All right, we are actually going to start with number 5 from the Venn diagram homework. We have got ourselves 3 sports that we're working with. Okay, so 1, 2, 3. Now, what do we know that may become helpful? Well, let's get these labeled first. All right, so tennis, rugby, and soccer. And I, again, am going to color code everything that we are working with. Just because this way, again, I can visually see what's going on. Okay, so each member of a sports club plays at least one of soccer, rugby, or tennis. Okay, so we don't have any nuns that are hanging out. The following is known. 43 members play tennis. Okay, that's going to be good to know later, so we'll jot that down. 7 play tennis and soccer. Here's where some of you have to be careful. When it says tennis and soccer, that doesn't necessarily mean it's just here. Tennis and soccer takes on this whole football shape, which means it could also include some students that do all 3, because they'd still be playing tennis and soccer. So I'm not going to fill in a number there yet, but I'm going to keep that in mind. 6 play soccer and rugby. So again, I'm going to have 6 that go into this area here that's split between those 2. 84 play rugby or tennis, which again will mean all of the numbers within these 2 circles will add up to 84. And then 68 play soccer or rugby. So again, all the blanks in the soccer and rugby circles I should be able to add up, and that's going to get me that. You're like, well, dang, we don't know much. And 4 play all 3. Okay, there's the one bit of info I know for sure right now. Now I can start working my way back towards the others. So anything where I'm told there's 2 things. So I'm told 11 play tennis and rugby, and I'm told 7 play tennis and soccer, and 6 play soccer and rugby. Okay, having that 4 just makes all 3 of those things easy now. 11 play tennis and rugby. Okay, tennis and rugby's here. I already used up 4 with all 3. How many do I have left for here? 7. Because here's all my tennis and rugby players. 7 and 4 is 11. Okay, so that one's ready to go. So then I move to tennis and soccer. Okay, so this group.
3.
Okay, already got 4, need 3. Check. And then finally, soccer and rugby are here. What number is going to go in here?
2.
2. So I got 4 and 2. Here's all my rugby and soccer, so I've got that set. So now I take the next logical step. I know how many total people play tennis, 43. That doesn't mean it's just here, it means in total. So far, I have 14 tennis players. I have 43 total. How many people are just going to play tennis? 29. Okay. So I've got one of my circles done. So then I start to look at what I have left to work with here. Let's see, what haven't I used yet? Okay, so I also know that 84 play rugby or tennis, and I know 68 play soccer or rugby. Well, hey, I already know part of the tennis here, so let's play with this. How many people do I have so far that I know of that play tennis or rugby? 36, 40, 43, 45. I only have 1 spot left. I already have 45 students accounted for. Yep, and there's 84 total. So this has to be 39. Because if I've done this right, I should get 32, 36, 43, 45, 84 students playing rugby or tennis. 11 are playing tennis or rugby. And it's like, okay, I can see how this is kind of working. So I've got all of that, and now I've finally worked down to the last piece of my puzzle. 68 play soccer or rugby. And I'm going to do the same process that I just did here. So I got 10, 14, 16. I have 55 accounted for already. There's 68 total. How many do I have left? 13. And so then to actually get the question that they're asking for at the end, how many members does the club have? You just add all of the numbers together. And I believe that totals up to 97. So that's how that one would work. But it's taking pieces. It's sort of like if any of you ever, when you were younger, maybe you do it when you're older, those clue books, and you do go through and you read, and you do all the clue things to start eliminating numbers, and you're like, wait a minute. Ooh, that's one more bit I know now. And you just keep going back through until things kind of clear up a little bit. But that would be our tackling of this, and we'd have 97 total numbers that we're working with. Again, on the test itself, will there be one that's this long? No. But it's always good to see how this works because we never can problem solve enough. We're going to take a look at our very last part of probability here, the difference between experimental probability and theoretical probability. And the first words, of course, are kind of indicative of what we're talking about. Experimental probability gets results from actual events. So when I'm flipping a coin, instead of saying, well, it's a 50-50 chance if I get heads or tails, I literally sit there and keep flipping a coin and seeing how often certain events happen. So for instance here, this would be my chart from my experimental probability. So let's see here. How many times did I get heads?
3.
I got heads 3 times. How many times did I flip a coin? 10. Okay. Now, is that normal for what we think? No. Because what we normally speak about when we're doing mathematics is theoretical probability. And that is results from what should happen mathematically. And so, as we've always said before, theoretically, my probability of getting heads should be 1/2. Or if I did it 10 times, it should be 5 out of 10. But again, when I'm doing it experimentally, one time I may get 3 out of 10, another time I may get 6 out of 10, I may get 1 out of 10. It's going to vary. But the more times I do it, the more it's going to come back to the mean. So if I do it 10 times, I may be way off. If I did it 1,000,000 times, I'm going to be pretty close to 50-50 more than likely. And that's where that comes from. So understanding what's going on, because that one word changes a lot of things. So for instance, and I think we're going to take a look at number 1. We're going to take a look at number 2. And we are going to take a look at number 7. And then I'm going to put you on your own for the rest here. All right, so suppose the spinner over here was spun 60 times and it stopped at the number 4 on the dial 14 times. What's the experimental probability that the pointer stops at 4? 14 out of 60. Which of course I then could reduce. But let's take that a step further. What would the theoretical probability be of that spinner stopping on 4 if I spun it 60 times? How many times should it stop on 4?
10. 12.
Okay, right. Because I know that on any number, theoretically, it should stop 1 in 5 times. But if I wanted to know how many times it would stop out of 60, well, that's pretty straightforward. Because 5 times 12 is 60, so I'd just multiply the numerator by 12. And I'd say, okay, it'd be 12 out of 60 times. And then I could reduce it back down to this. But if you were asked how many times, that's how you'd go about doing that. Oh, gee. So what do? I just answered number 2 and number 1. That was awesome. What's the theoretical probability that the spinner will stop at 4 on the dial? Okay, so I got a little ahead of myself. But again, that's the difference between those. So again, got to be a little cautious. So if I roll my way all the way down to number 7 here. All right, we've got a poll of seniors. Showed that 110 favored Thu Pham.
Who?
Yeah, for senior class president. 100 favored Aurora Martinez, and 40 were undecided. How many seniors were polled? 250. What's the experimental probability that a randomly chosen student would vote for 2?
I know that data. But no, there is.
How many people in the poll voted for him or her? I'm not sure. What's that? 110. And 250 seniors polled. And it's much different when you're taking like a voting poll to do theoretical, because theoretical basically would say everybody gets the same number of votes, and that's kind of crazy and ridiculous how often that doesn't happen. So here, having experimental probability would probably be more of a realistic way of looking at it. Okay? So again, not a tough concept. I thought it'd be a good one to put here at the end. So now your focus will become finishing off these other, 2, 4, 6 problems? 5 problems, I can count. And then working on at least the 1-page review. But when you've got the rest of today, plus we're going to be talking about this stuff Monday, I'd go get the extra points while I can, because they could come handy at the end. I'm just saying.